Hello everyone, welcome to another physical science lesson, and today we're going to be looking at some important ideas about how you can strengthen your thinking about physics. So I've called this lesson Thinking Physics. So when we talk about thinking physics, what do we really mean? The first thing is that we want to get an overview of what the physics content is all about. So what are the topics in physics? Well, the core knowledge is divided into things called mechanics. Then there's a section on waves, sound and light, electricity and magnetism, and some parts of matter and materials. Now, please remember that there's a lot more to physics than these topics that we do at school, but these are the important ones. And if you look at the structure of your curriculum, you'll see that in total, there are two that stand out that are really important. So the mechanics and electricity and magnetism carry the bulk of your marks. So you really do need to have a good understanding of these. But apart from learning and knowing some details, you also need to grapple with some skills that can be asked in all of the topics. So what I want to emphasize here is the skills involve the design of investigations, representing relationships, application of principles to real-world situations, and they all lead in some way or another to calculations. So if we're thinking about physics, we have to recognize this as a fascinating subject. It requires lots of questioning and reasoning, and so it is very interesting. This is something that you should create some curiosity about. So look around you, look in the world, and ask questions about these things and see if you can apply what you're reading and learning about in class to real situations. So here is a question I would like you to consider. What is the best way to study and master physics? Well, you know, there are lots of different ways. People study in different ways, and we don't want to have a recipe, so to say, that everyone must do this. But there are some principles we want to bring out in this particular lesson to say, try these ideas, and here's some guidance to help you in your preparation and in the answering of questions. Because whatever you do, you're going to need to make sure that you have the kernels, the principles, to be able to solve the questions you're asked in your final assessments. So let's kick it off by saying, what's the starting point? And the starting point, like many other subjects, is we've got to have definitions. And this includes terminology. So if we recognize that there are words that we use in physics that are slightly different to the everyday words, we need to make a list of those and link them to the definitions so that we are very clear about what the meaning of critical words are. We also need to recognize that definitions link to formulae. And here's the important thing. When you're doing a formal assessment, those formulae are given to you. It's one of the advantages of this subject, is the way it's assessed, is that you can take with you, or you are given, a data sheet that has a whole lot of useful information. And here's a trick that I've learned, is even when I was at school, I was told, write down your definitions and annotate on a data sheet. It can help you then remember in the exam. You're not going to have everything written out on your exam sheet, but it will trigger for you the things that you will need to learn. So let's have a look at the data sheet. So the first thing is that there are a number of tables, and table number 1 deals with the physical constants. Don't be confused. You will get a data sheet that might not only be in English. This one's in English and in Afrikaans. But it is important to recognize what is written there. These are constants, for example, the acceleration due to gravity, little g, and it gives the units for that, the value and the correct SI unit. you'll see that there's a universal constant, big G. And so we could go through each of them. Recognize what each of these constants relates to. So this one relates to Newton's laws. So I'm going to say Newton. This one relates to the speed of light, and we can work out this. It relates to electrostatics. And so as you're going through, recognize what each of them relate to. And that's really important so that you can start to make meaning when you've got the data sheet in front of you. Try and make links between the constants and the formula. So table 2, which is written underneath that constant table, you'll see that they've got slight headings like motion and force. So you've grouped together your formula and you can see what they're related to. In the next part of the table, this is electrostatics. And then we've got electromagnetism, we've got circuits. And so it's very important that you take a note of each of the pieces of information. Recognize the formula. And as you're studying, what's important is that you start to annotate onto these sheets, onto this data sheet. Keep it on your desk, pin it on a wall, and every time you're adding a new topic, add writing to it. It will help you consolidate your information and your learning and help you remember. And then perhaps once a week or every second week, you take a blank data sheet and see if you can write everything down, all your definitions, all the formula, and you can annotate and recognize what's right. Now, in terms of using the data sheet, it's important that you identify vector quantities, that you recognize each symbol, and that you also learn the SI units for each quantity. And so it's creating those links that is very important for your ability to recall. And so I want to show you as an example. Go to the table again and recognize that we're going to be looking at vector quantities. You might say to yourself, what are vector quantities? Those are things that have magnitude and distance, direction, and we can always draw a vector diagram when we're answering those sort of questions. So if we go to the data sheet here and we're saying what are the things that are vectors, I might just make a little V there, or an asterisk with a V, because that's a vector, that's a vector. Time isn't a vector. Velocity is a vector, initial velocity is a vector, acceleration is a vector. And change in position is a vector. I go to net force, acceleration, force. Those are all vector quantities. What we need to recognize here is this is the force of kinetic friction. This is the force of static friction. That's weight, that's acceleration due to gravity. And so you recognize that there are vectors all over the place, but they're mainly in mechanics. However, there are some in electrostatics as well. So if we go to the next page, you'll recognize here is the force vector, and here is the electric field strength vector. So this is also a vector, and so we need to note it and to make sure that we've got it very clearly. Please note that in terms of electricity, we don't have vectors. There are no vectors here. In terms of the value of phi for electromagnetism, we recognize that the magnetic field strength is a vector, but we're doing a product there, multiplying them together. Phi is not a vector. Okay, so we are very clear about what is a vector and what isn't a vector, and that should be very clear in our heads. Every topic that has vectors, because when you come to check your answers in that section, you must check that you have a magnitude and a direction with the SI unit that is the correct SI unit for that value. Okay, so that is incredibly important. So as I've gone through these tables, please also note that perhaps in a different color, you're going to take note of the units. So we're going to say velocity is meters per second, acceleration meters per second, and we can go through that sort of process. The other thing is to identify formula, relationships with the formula, to identify what the constant is and to link them to the definition. So let me give you an example. This formula here is linked to Newton's second law. This formula here is linked to the universal law of gravitation. And so we can carry on and we can link the laws together and make sure that we understand how they link. In terms of the constant, you'll see that's the constant, which is capital G, and that's the little g from the values of the constants. So I hope you're seeing that this data sheet can be very useful in helping us summarize and pick things together and also link together. There is the universal law of gravitation, and we've got the units. Please notice that these units are compound units. It's not just newtons and something else. It's newtons, meters squared, kilograms to the -2. And so you must be very clear that you check the units of constant and recognize we can change things and check them in terms of, are they kilograms, are they meters, are they seconds? So for example, we can take newtons and we can say that is kilograms times meters per second per second. 1 newton is 1 kilogram times meters per second per second. So units help us very much to check that we're on the right track. And so in this sort of starting position, we're starting to think more like physicists. You know what? That thinking takes a little bit of energy. So why don't you take a short break, and we'll be back to support you in developing your muscles in physics. That is not your arm muscles or your leg muscles, but your brain muscles as we continue to think about physics.